Okay. So I'm just gonna, again, I'm just gonna add a blank page just to, as kind of scratch paper right now. And so this is gonna be dealing with a unit circle, but I wanna just remind us about 30, 60, 90s and 45, 45, 90s. I'm just gonna come over and grab a triangle from here. If I want, sorry, it's off the side of that. If I want a triangle, I'm going, a right triangle, I'm gonna hold the shift. And let's say I've got this right triangle. Okay, whether I want to make it officially a 30, 60, 90, if I could do that. Pretty close. Doesn't matter. But when we're dealing with, for example, a 30, 60, 90, in this case, always, this is going to be our hypotenuse, okay, because it's the longest side. Whatever is the shorter side, that's across from the shorter angle. So in this case, this would be a 30 degrees and this would be a 60 degrees. Now, when you're dealing with a 30, 60, 90, whatever's across from your 30, I'm just going to call it X temporarily. You double that and you get what is your hypotenuse. You times what is across from your 30 by root 3, and you get this. Now, what we're going to be dealing with, and I'm just going to select this with the annotate. Do is I'm just going to come here to the select. I'm going to select this. I'm just going to copy paste so I don't have to redraw it again. Then I can always come and get rid of what I want. So I'm just going to get rid of these things. Now, what we're going to be doing is we're going to be dealing with something called a unit circle. A unit circle is a circle of radius 1. Your hypotenuse is going to be your radius of 1. So we're going to have a 1 here. Now, if I have a 1 here, remember, across from my 30, I double this to get this, or this is going to be half as much. So if this is a 1, then this is a 1/2. It's half of it. Then I take what's across from my 30 and I multiply it by a root 3 to get this. And when I multiply this by root 3, it's going to multiply with my numerator. So I'm going to write it as a root 3 over 2. Okay. Now, if I was dealing with this, and I'm going to draw another right triangle next to it, and then this time I'm going to have it be a 30, 60, 90, where this right here is my 30 because across from it is my shortest side. This is going to be my 60. So again, if my hypotenuse is 1, across from my 30 is going to be half of that, which is a 1/2. I take what's across from my 30, I times it by root 3, and I get what's across from my 60. So it's going to be root 3 times 1/2 or root 3 over 2. We need to know these values here. These values are going to be on our unit circle. We're going to start doing some sine, cosine, tangent where we're not using a calculator to compute it, okay? You're going to give me answers in exact form, not in decimal form. So that is our 30, 60, 90s right here, okay? So these ones here was the 30, 60, 90 right triangle. I'm going to now just real quick talk about a 45, 45. Okay. So I'm going to grab another triangle. And I'm going to make it a 45. It doesn't have to be perfectly a 45. Okay. So let's say there's my 45. So in this case, if it's a 45 here, if it's 45 degrees here, it has to also be 45 degrees here because of that 90. Now, for a normal situation, my two sides of this, my legs, are across from my 40s. That means they have to be the same value. This is really an isosceles right triangle. So whatever this is, so is this. To get my hypotenuse in this case, I'm going to take my leg, either one, which is x, and I'm going to times it by √2. And that gives me a 45, 45, 90. So if I'm dealing with a situation, I'm just going to come and select this. So I don't have to redraw it. Okay. So if I'm dealing with a situation, let me get rid of these, where my hypotenuse is a 1. What I'm doing is I'm going backwards. I am taking whatever's here, timesing it by √2 to get this, but going backwards, I'm going to do the math on the side. I'm taking my 1 and dividing it by √2. That's how I'm getting these. Because here, I times this side by √2 to get this, but going backwards, I would divide by √2 to get my x. So I'm taking my 1, dividing it by √2, and I get 1 over √2. We do not like to leave radicals in our denominator. We do something called rationalizing. So I'm going to multiply the top and the bottom by something that will make this irrational rational. Basically, I need to make this not be a square root of something that's not a perfect square. So what I'm going to do is I'm going to multiply it by a √2, because a √2 times a √2 undoes. A √2 times a √2 is a √4, and the square root of 4 is 2. Another way to think about it, if I take a √2 times a √2, I'm just going to jot this here. I'm really taking √2 squared, and the square undoes the square root, which leaves me with the 2. Okay, you can think about it that way, or again, you can think about it as √2 times √2 is a √4, but what's the square root of 4? 2. Both of these cases, I'm going to end up getting a 2 on bottom. And on top, I'm going to have a √2. That's what these sides are going to be, √2 over 2, √2 over 2. These values are the values that we're going to be having on our unit circle when we start dealing with our unit circle, okay? So I just want us to kind of have these values, understand where these values are coming from. And so again, this was a 45, 45, 90 right triangle. Okay, so now I'm going to go back up to the unit circle, okay, which is our official thing we're looking at. And when I'm looking at this, we are going to be learning about something called degrees and something called, well, we know degrees, but something called radians. Let's first start with our degrees, okay? So in a circle, all the way around the circle is 0 degrees. I mean, sorry, it's 360 degrees. When we're dealing with this unit circle, we are going to have, and I'm going to draw it in, I'll just do it in black. I'll just do it a little darker than this. We are going to have a, maybe I'll actually use the line because, okay, this right here, let me make it thicker. This right here, you guys see me drawing that? That is our y-axis. This going across is our x-axis. That center, okay, the very, very, very center right here is going to be 0, 0. That's our origin. Okay, so that's going to be 0, 0. That's what that point is. This is a circle of radius 1. So what that means is, as I'm going on the circle, I'm going out. This point right here, I'm going to be at 1 because my radius is 1, 1, 0. That's going to be where I am here. Okay. Over here on this side, again, this is also 1. This is going to be negative 1, 0. Going straight up, this also is a radius of 1. This is going to be 0, 1. And going down, this again is a radius of 1. So this is going to be 0, negative 1. We're going to be filling in these coordinates dealing with the angles I was just discussing. Now, I'm going to fill this in degrees. So if I'm going around a whole circle, it's 360 degrees. What's going to happen here? And I'm going to grab a color. So choose a color, whatever color you want. Make it so that it's not super thin so you can see it. And actually, maybe I'll do it with the line so I'm just straighter. So I'm going to pick a color. Okay. I'm going to start up here and I'm going to draw a line all the way to here. Okay. So I'm going to draw a straight line across like this. And I'm going to do the same thing over here. Do you see how this is like my first marking above? I'm going to come over here on this side and also do the symmetric one right here. And I'm going to connect this to here. These four angles are going to be corresponding with one another, okay? Now, what this is going to represent is this is going to represent 30 degrees, okay? The ones I just drew, I'm 30 degrees above my x-axis here. I'm 30 degrees above here. I'm 30 degrees below here. I'm 30 degrees below here. So I'm gonna color code. So if I'm talking about this angle right here, and I'm talking about from here to here is what I'm talking about, okay? That angle is going to be 30 degrees. Let me make it a little fatter. That angle is going to be 30 degrees. And again, I'm talking about from here to here. That's 30 degrees. Now, all the way around a circle is 360 degrees. So let me write here first that this right here is going to be my 0 degrees. Going all the way around back to this spot, I'm going to travel, and here, I'm going to do that in a different color. I'll just do it in black. So this one is 0 degrees, and this is 360 degrees, okay? This over here is going to be half of 360, which is 180 degrees. So when I'm trying to figure out these other angles, and I'm going to get my pink back, this is 30 degrees above. This is going to be 30 degrees, basically 30 degrees above this or 30 degrees short of my 180. So I'm going to be at 150 degrees. I'm 30 degrees up over here. And here I'm also 30 degrees up. Okay. Now, if I'm 30 degrees above, then here to this pink, I'm 30 degrees below. So if this is 180 degrees, this is going to be 30 more, which is going to be 210 degrees. So again, this first one's 30. This is going to be 30 short of my 180. I was 30 above it. Here I'm 30 beyond it. Now here, I'm going to be 30 short of my 360. Okay, I'm 30 short of my 360, which means this is going to be 330 degrees. Now, the next mark, I'm going to choose a different color. Okay, it doesn't matter what color, just choose a different color. And that one, I'm going to come from here to here, going straight across. I'm going to do the same from here to here. So you see here, I'm at the second one above. I'm at the second one above. I'm at the second one below. I'm at the second one below. Okay, need to have a mirror image. Now for this one is going to be 45 degrees, 45 degrees. That's what that's going to be. And when I say 45 degrees, I mean from here to here is 45 degrees. Okay. From the x-axis to there is 45 degrees. Well, over here, I'm going to be 45 degrees short of 180. 45 degrees short of 180. So that's going to put me at 135 degrees. I'm basically just taking 180 minus 45. Then when I'm going down, I am going to be going 45 degrees beyond 180. So if I add 45 onto 180, I get 225 degrees. Okay, I'm just adding 45 on and 45 beyond. And I'm also going to be 45 degrees to here. So that means I'm 45 degrees short of 360, and 45 degrees short of 360 is going to be 315 degrees. Now I'm color coding these because these are all going to be corresponding to each other on our unit circle. They're all the same XY coordinates, but maybe the signs are positive or negative depending on what quadrant we're in. So again, I went 45 above 0. I was 45 short of this 180. So if I'm 45 short, I'm up at 135. I'm 45 beyond 180, so I added 45 on. And here I was 45 short of my 360. So I'm going to choose another color. And I'm going to now take the one that's the third one above. And again, I'm using the line tool, just easier using the line tool, because if I'm drawing this, it's going to be a mess. Okay. So this case, this is going to be my 60 degree. Okay. This is going to be 60 degrees. That's what that is. And so when I'm saying 60 degrees, from here to here is my 60 degrees. Now, this one here, I was 60 degrees short of 180. So when I'm going from here to here, I'm 60 degrees short. I'm at 120 degrees. Okay, I'm 60 off of 180. Below, same idea. Okay, so for me to go down to that orange one, I'll move it here in a second. From here to here, I'm going to go 60 beyond 180. So I'm going to add 60 onto 180. And I'm going to be at 240 degrees. And on this side, I'm going to be 60 degrees short of it. And if I'm 60 degrees short of 360, I'm at 300 degrees. Now, the ones that I had darkened in black, the ones that are on the x-axis and the y-axis, this is 0 degrees. This all the way to here is 180 degrees, which means halfway in between is 90 degrees. Okay, so this one up here is going to be our 90 degrees. So either think about taking 90 off of 360 going backwards, or adding 90 onto 180, whichever way you want to think. This is going to be 270 degrees. Let me make that 0 better. 270 degrees. Okay. Now, the next thing I'm going to talk about, and I'm going to color code, are the points that are on this unit circle. Okay, unit circle radius 1. So I'm going to focus in on, and here, let me label these quadrants, okay? This one here is quadrant 1. This side over here is quadrant 2. Down here is quadrant 3. And over here is quadrant 4. And we write them normally in Roman numerals. Okay, it's usually how we'll write them. So again, quadrant 1 is what we think of as a positive XY axis, and then it goes around the circle as I'm going around the degrees. Okay, 2, 3, 4. Okay, so 2, 3, 4. So I'm going to focus on quadrant 1. And first thing I'm going to do is start at my 0, 0. And what's happening here is, again, this is 0, 0 right here. That's 0, 0. So as I go out a radius of 1, I am literally at 1, and make it black. Okay. I am at 1, 0. That's where I'm at. Which means straight up here at the 90 degrees, I'm at 0, 1, because I'm going 1 up. Okay. So again, I'm 1, 0, because again, this is like a graph, XY axis. This is 0, 0 right here. And then here, I'm not going left or right. I'm 0, but I'm going up the radius, which is 1. So 0, 1. So that means over here at 180, I'm going to go out 1, which means it's a negative 1, 0. So over here, I'm going to be at negative 1, 0. Okay, negative 1, 0. On the down at 207 degrees, I'm going to be at 0, negative 1. So this is going to be 0, negative 1. Okay, so 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now I'm going to deal with my pink ones. Now for this, if I was to get a triangle, I'm going to get a triangle. I'm going to get a pink triangle. I'm going to hold shift. So I get a right triangle. And I'm going to come here and I'm going to drag it like this. This triangle right here, okay, is 30 degrees here because that's the 30 degrees. This is 30 degrees. That means that this is 60 degrees. So this is a 30, 60, 90 right triangle. So the side of, well, this side right here is 1. That's my hypotenuse, okay? The one across from my 30 is my shorter one. And if we look back here, across from my 30 is my 1/2. This length here is my longer side. This is a √3/2. So that 1/2 is going to be the y coordinate, because that's my y direction. And this √3/2 is going to be my x coordinate. So I'm going to come back here. And for my coordinates, I'm going to write that going this direction was my √3/2. This direction is my 1/2. So I'm going to use that as the fraction bar. √3/2, comma, 1/2. That is that point. Again, because this right here would be my 30 degrees, which means up here would have been my 60 degrees. And so if this is a radius of 1, which is my hypotenuse being 1, it is the same as this triangle. And this is just how I'm moving to get to this point. To get to this point, I'm going this direction, this direction. So to get to this point right here, I'm going this, which is √3/2, comma, this, which is 1/2. Now, the reason I did all these pink ones in pink or whatever color you are using is because all of the other ones are going to be the same coordinates because it's the same distance. It's just I'm in quadrant 2, I'm in quadrant 3, I'm in quadrant 4. So what that means is this point over here is still going to be a √3/2 and a 1/2, but it's going to be a negative √3/2 and a positive 1/2 because that's the quadrant I'm in. My x's are negative, my y's are positive. So positive negative √3/2, positive 1/2. So I'm going to do negative √3/2, positive 1/2. And I'm zooming in to do this, try to write these in, okay? Some of us like to keep it really tiny. It's hard to write tiny on tiny, so zoom in. So again, it's the same as this one over here. This was √3/2. This is going to be negative √3/2. This was 1/2. This is still 1/2. That means this one down here is also going to be negative √3/2, but it's going to be a negative 1/2 because that's the quadrant I'm in. Negative x, negative y. So this is going to be a negative √3/2, comma, a negative 1/2. Which means on the other side, over here, this is going to be a positive √3/2. And when I go down, I'm going down like this, it's going to be a negative 1/2. So this is going to be a positive √3/2 and a negative 1/2. So all of the coordinates for the my pink ones are the same. √3/2, 1/2. It's just the sign changes depending on if I'm in quadrant 1, which is positive x, positive y. Quadrant 2, which is negative x, positive y. Quadrant 3, which is negative x, negative y. Or this quadrant 4, which is a positive x, negative y. So I'm going to jump to my orange ones, which is my 60 degree. So I'll get a triangle one more time. I'm going to start right here up at the point, and I'm going to drag it down to the center. That is my triangle that corresponds with this. My 60 degree, remember, is going to be from here to here. That is going to be my 60 degrees. Okay, that's going to be my 60 degrees, which means up here is my 30. Okay. So what's happening is it's going to be the same exact √3/2 and 1/2, but now this is my 1/2. This is my √3/2. My x is my 1/2. This is my √3/2. So this is going to be 1/2, comma, √3/2. So my 30 and 60 are the same coordinates, but reversed. Okay, because it's the same triangle, so I'm just at a different spot on the triangle. One of them I'm at the 30, the other one I'm centered at the 60. So I can go through and fill in the rest of these. In this quadrant, it's going to be negative, comma, positive. So it's going to be a negative 1/2 and a positive √3/2. Okay. Again, same coordinates as this. It's just I'm in this quadrant, which is negative x, positive y. And I'm going to come down to these. This quadrant is negative x and negative y. So this is going to be a negative 1/2 and a negative root 3/2. Which means in this quadrant, quadrant 4, positive x, negative y, positive 1/2, negative root 3/2. And then the next one I'm going to look at is my 45, 45, 90. Okay. And my 45, 45, 90. If my 45 is here, this is root 2/2. This is root 2/2. They are the same. Okay. So I'm going to come up here to my 45. I'm going to hold shift and I'm going to start up here. And I'm going to drag it to the center. And that's the triangle that I'm looking at right now is this one. And I'm just going to maybe make it a little easier for us if I shade this in. That's that one. That's my orange one. I'm using the highlight, freehand highlight. Now, for this one, again, this angle here is my 45 degrees. That's what that angle here is. But regardless, it's a 45, 45. So what that means is here, this is going to be root 2/2, comma, root 2/2. And then I'm going to fill that in each of the other ones, just changing the signs depending on my quadrant. So this quadrant is a negative x, so negative root 2/2, and a positive y, so a positive root 2/2. Okay, all of these here where my x's are negatives, my y's are positives. These ones here, negative x, negative y. So this is going to be a negative root 2/2. Zoom in. And a negative root 2/2. All of these, the x and y's are negative in this quadrant. In my last quadrant, my x's are positive because I'm on this side, and my y's are going to be negative. So this is going to be a positive root 2/2 and a negative root 2/2. And that's our unit circle. We are going to have to start memorizing this, knowing these values, knowing the angles, knowing the coordinates. Okay. How are we doing so far? So play it again. That was a radius, take the radius, wrap it around. That is 1 radian. So on our calculators, I kept saying for most of this year, make sure your calculator's in degrees. Now we're talking about radians. This is a radian. It's not in degrees. It's in how many radii are going around the circle, where you are in terms of the radius being around the circle. So if I go back to our worksheet, and you see here that if I was to calculate 1 radian, it's about 57-ish degrees. That's what it's equal to, okay? Now here, if I click on this one, is it the same one? No, yeah, here, I've got it here. Let me do it here. I'll put up a new one. So if I click here, that was 1 radian, 2 radians, 3 and a bit. That bit is 3.14, so pi is half of a circle, which means that the whole entire circle would be 2 pi. We're going to be dealing with pi for our radians, okay? So all the way around a whole entire circle is 360 degrees. All the way around a whole entire circle is also 2 pi radians. Halfway around is 180 degrees. And 180 degrees is really 3 of your radians plus this portion, which is about a 0.146 of it, which you see is pi, okay? So, I'm going to have you guys unsubmit because we did not finish our radians on our unit circle. So let's unsubmit that. I'm sorry, I should not have said submitted it. Okay. So now we're going to talk about something called radians on our unit circle. Okay. So when we are talking about radians, which you see there's this other blank spot that they left here, that's for our radians. So this one is our degrees, this one's our radians, this one's our degrees, this one's our radians. So I'm going to start off with the same color I did for 360, 90, 180. Okay, my 0 degrees right here is going to be 0 radians, 0 degrees and 0 radians. Okay, so this was 0 degrees. Here it's 0 radians. When I go all the way to here, which is 180 degrees, we saw that that was the same as pi. Which means going all the way around from here to here is pi. And that means going from here to here is another pi. So that 360 is going to be 2 pi. That's 2 pi. Okay, so I have 0 radians, pi radians, 2 pi radians. Now, when I'm going from here to here, if this is pi all the way to here, this is half as much. So we're going to call this pi halves. Half a pi, pi halves. So if I think about this as being 1 pi half, this is a 2 pi halves, and 2 pi halves is really just pi. So I have 1 pi half, 2 pi halves, and coming down here, this is going to be 3 pi halves. And going all the way back here would be 4 pi halves, but what's 4 over 2? 2. So again, it's pi all the way to 180. Halfway is pi halves. So going from here to here is 1 pi half. This would be 2 pi halves, and I'm going to jot it down temporarily. So 2 pi halves is, if I reduced it, the same as pi. You don't need to write the 2 pi halves. I just want you to see that's the same as pi. 2 over 2 is 1. Okay. So if I'm trying to split this into halves, this is 1 pi half, 2 pi halves, which is a whole, 3 pi halves, 4 pi halves, which is 2 pi's. Now, those were the nice ones, okay? These other ones, these pink ones were 30 degrees, right? How many 30s are in 180? So 30 goes into 180 6 times. So what this means is this, and I'm going to change it to pink here. This 30 degrees, I'm just trying to find where, okay, this is it right here. So 30 degrees, and this is it. 45 with this, 60 with this. This 30 degrees, if 30 degrees is 1/6 of 180, it's also 1/6 of pi. So this is going to be pi 6. Pi 6. It's a 1/6 of pi. Because 30 is a 1/6 of 180. Now, what I think about is the same way I thought about this. I was 60 above, 60 below, 60, I mean, no, sorry, this was 30, right? I was 30 above, 30 below, 30 above, 30 below. I'm going to think that same way. I'm pi 6 above. Okay, here, I'm going to be pi 6 short of pi. So I'm going to write it this way temporarily. So if I'm dealing with 6, I think of pi as 6 pi 6. That's really a whole. 6, 6 is a whole. Well, I'm 1 pi 6 short. So if I'm 1 pi 6 short of 6 pi 6, I'm at 5 pi 6. So again, this 30-degree angle, there's 6 30s making this up. So this is 1/6 of the way. So that means it's also 1/6 of the pi. So that's why this is pi 6. Now, if I'm thinking about going all the way around to here, yes, it's pi, but think of it as 6 over 6, 6, 6, which means here, this is 5 pi 6. Which means if I go 1 beyond it, I'm going to be at 7 pi 6 because I'm a pi 6 beyond. Now, if this is 6 pi 6, which is really pi, and I have another 6 pi 6, that would really make this, and again, I'm going to erase this in a minute, 12 pi 6. Because 12 over 6 is 2. So I'm thinking of all of these as a 6. So this is 6, 6, 12, 6. So if I'm a pi 6 short, this is going to be 11 pi 6. 11 pi 6. Okay. Now, I'm going to erase my 6 pi 6 and my 12 pi 6 because really that's just a 2 pi and a pi. I'm just trying to write it to help me. So now let's think about the 45 degrees. How many 45s in 180? Well, if you think about 90, 90 is 2 45s, right? So 180 is 4 of them. So what that means is my teal one, which is my 45 degree, is going to be pi force, because there's 4 45s and 180, which means if I'm thinking about pi, this would be pi force of it. Pi force of it. Now, if I'm in this quadrant over here, again, I'm going to think of pi as 4 pi force, because I'm dealing with force. 4 over 4 is a whole. So if I'm 1 pi short, not 1 pi, sorry, a pi force short of this, I'm going to be at 3 pi force. 3 pi force. And if I'm a pi force beyond 4 pi force, which is pi, I'm going to be at 5 pi force. Now, I thought of this as 4 pi force, which is just pi, and 4 pi force plus another 4 pi force is an 8 pi force. So that means that this one here, which is short of this by a pi force, is going to be 7 pi force. So for each of these, I think about, if I'm dealing with 6 pi 6, I think of my pi as 6 pi 6 and 12 pi 6. If I'm dealing with my force, I think of it as 4 pi force and 2 pi as 8 pi force. And I'm always thinking above, below, above, below. That's how I'm always thinking. There really are more force going around. There's really more 6 going around, but they reduce down to either thirds or halves or something we already have. So we're always thinking about it above, below, above, below. Okay. My 60 degrees. Well, how many 60s in 180? 3. 3 60s in 180. So my orange one here is going to be pi thirds, because a third of 180 is 60. So a third of pi is pi thirds. Now, again, since now I'm dealing with thirds, I got rid of my 4 pi force. I'm going to think of this as 3 pi thirds, because I'm dealing with thirds. So if I'm 1/3 or 1 pi thirds above, I'm at 2 pi thirds. Which means when I go this direction, I'm going to be pi thirds beyond 3 pi thirds. I'm going to be at 4 pi thirds. We all getting this down? If this is 3 pi thirds here, again, which made this 4 pi thirds because I'm 1/3 beyond. 3 pi thirds plus another 3 pi thirds would make this 6 pi thirds. So this one down here is going to be 5 pi thirds. Okay. And that's our unit circle. And so now you can submit that. So just like the one I gave you, I have one here that's just breaking things down to just in radians, just in degrees, so it's not so much on it at one time to look at. This one has just the coordinates. Now, what you'll notice is I have here cosine of theta, comma, sine of theta. The green are your cosine. The red are your sine values for each of these angles. So if I asked you guys, okay, what is the sine of 30 degrees? Okay, I'd want the y coordinate of this point. And the y coordinate of that point is 1/2. So if I put sine of 30 degrees in my calculator, it would give me a 0.5. If I put cosine of 30 degrees in my calculator, it's not going to give me a √3/2, it's going to give me a decimal. We're going to have to give me the exact √3/2. So all of these are the cosines, all of these are the sines. And the reason that is, if I get to this for, not that one, the one I was writing on. Is if I'm here at 30 degrees, cosine is adjacent over hypotenuse. Adjacent, which is √3/2, hypotenuse is 1. So it's just √3/2. My sine is opposite over hypotenuse. 1/2 over 1 is 1/2. So on the unit circle, the coordinates are going to be, these are going to be your cosines, these are going to be your sines. Because it's a unit circle with a radius of 1, your hypotenuse is 1. So back to my paper here. So the way I think about this, okay, and it's kind of drawn here, your sine are the up and down, it's your y's, the cosines are the cross. So coming this direction's cosine, going this direction sine. Cosine, sine. So if I wanted to get up to this point right here, which would be my 60 degrees, that would be 1/2 comma √3/2. The 1/2 would be my cosine, the √3/2 would be my sine. I remember it alphabetical, just like x, y. X comma y, alphabetical, x comes before y, cosine comes before sine. The other thing I remember is I remember the lengths, because the √2/2 is kind of the easy one to remember because the x and the y are the same. These ones are a little more complicated because they are exactly the same coordinates but flip-flopped. So the way I think about it is thinking about the size of them, where if I'm thinking about a 1/2, 1/2 is your short length compared to √3/2. So my 1/2 is my short, my √2/2 is my medium one, and that's the one where they both are in the middle here. And my √3/2 is long. So when I'm looking at this and I'm trying to figure out, okay, what is the cosine of, let's say, this angle here, which is going to be 210 or 2 pi thirds. I would go, okay, well, how am I moving here? I'm moving short, comma, long. Short, comma, long. Where this one here, I'm going long, comma, short. Long, comma, short. Every time I say long, I'm thinking √3/2. Every time I say short, I'm thinking 1/2. Okay? That's kind of how I think about these things. Now, something else that we're going to be seeing is tangent is your sine over cosine. Okay. So in this case, if I'm on the unit circle, it's going to be my y over x. My cotangent is something new. It's the reciprocal of this. My secant is the reciprocal of my cosine. My cosecant is my reciprocal of my sine. Now, when I'm trying to remember which one, I think tangent and cotangent are easy ones to remember because they both have tangent in it. But if I'm trying to think about secant and sine, secant and cosecant, and I'm trying to figure out which one is the reciprocal of cosine and which one's reciprocal of sine, I remember S doesn't go with S and C doesn't go with C. So S is secant. So it's going to be reciprocal of not the S, but of the cosine. Cosecant starts with a C. C doesn't go with C, so it's going to be reciprocal of a sine. I know it's a lot of information today. Trying to get a lot of information out to us. I'm not expecting us to master all of this today. Okay.